Okay, recall that in the previous section, we had something like 2x plus 3y equals 12. Right? And I came in and said there's infinite many solutions. Right? If we were to put all the solutions that existed, or as many as we could write, all the solutions that we could write, they should look like a line. So that's what we're going to call this, graphing linear equations in two variables. Right? Two letters, x and y. Linear equations, notice how it starts with the word line. So linear equations are points, or the solutions, that once you put them and you see them, they're going to represent a line. So let's take a look at what I mean. Graph the linear equation 4x minus 5y equals 20. Remember how we used to do, like I used to give you guys an equation, and I will have like some values of x and y. The values were just random numbers. Like for example, I could have this to be 0, 1. I could even have a negative 1 for x. Like the values of x were just random numbers. So do that, and then put three random numbers of x. The bigger values you deal with, the bigger answer you're going to end up getting. Now that we have those, now that I have the x equals 0, solve for y. What I mean with that is, imagine I have 4 times 0 minus 5y equals 20. I know 4 times 0 is 0. So I have 0 minus 5y equals 20. Right, we can say subtract 0 from both sides. Negative 5y equals 20. Then we can agree that y equals negative 4, right? If I divide both sides by negative 5, I don't do it over here because of the space. Y equals negative 4. So we have that value. Then do it again, but now x equals 1. So let me start it over here for the space. I'm gonna go 4 times 1 minus 5y equals 20. This is 4. All right, 4 times 1 minus 5y equals 20. Let me subtract 4 from each side. Negative 5y equals 16. Let me divide both sides by negative 5. 6, so this is negative 16 over 5. It's like 3.2. So this is negative 3.2. Now let me do this again. But now I'm going to do the value of x to be negative 1. So I have 4 times negative 1 minus 5y equals 20. I know this is negative 4. So negative 4 minus 5y equals 20. This 4, let me move it to the right as a plus 4. So I have that negative 5y equals 24. Divide both sides by a negative 5. I know positive divided by negative is negative. 24 divided by 5 is like 4.8. Let me do this. Right, we could continue. We could go on and on. We could find many, many solutions. Now what we're going to be doing is we're going to plot those points in. 0, negative 4, right, on the x-axis. Remember, this is the x. The one going up and down is the y. Starting here on the x-axis, I'm not going to move, right? I'm going 0 spaces. I'm just going to go 4 down. So it gives me that point. Now, for the second point, right, if you guys want to see it as parentheses, I'm going to go 1 on the axis, on the x-axis, so 1, and I'm going to go down 3.2, which is about here. Now, on the other one, let me go on my third one. I'm going to go negative 1 on the x. I'm going to go to the left, and I'm going to go negative 4.8. So I'm going to go negative 1. Negative 4.8 is like 1, 2, 3, 4, almost 5. Just a little less than 5, so it's about there. Your points, the reason why we do 3 points, you see how they reflect a line? Now, just connect them. Your answer should look something like this. you have the tools on your My Math Lab. You have the tools to be able to make straight lines. So you just have to connect a point here, another there. So it was going to make a line. So once again, the reason why we do 3 points is because we want him to look like a line. A way that we will know that we're doing it wrong is, imagine I had a point here, so there. Then I had another point here, so I kind of have an idea where the line is. But then my next point is like over here. So you notice how it looks like I'm doing a line, but one of them is off. So that's how I know that I did a mistake somewhere. It's probably I made the mistake in that point. Probably I made the mistake on that one or that one. Once I see my points do not make a line, there's a mistake somewhere, but it's not necessarily the last point or the point that we consider off. So that's the reason why we do 3 points, because that way we can check our work. Now here, for example, we're going to move into what we call the intercepts. See how the x-axis, here it is, the x-intercept, we're going to call the x-intercept the point that crosses through the x-axis. The important thing on the x-axis is whatever point you choose, it could be this point, it could be this point, any point you choose, the y value, like for example, this point is the point 20, this other one is the point -10, and this other one here it is -30. Notice that anything on the x-axis, the y value is 0. So for me to find the x-axis, when I do my table, I'm going to say y equals 0. That's going to give me my x-intercept. Once again, intercept is where it crosses. Now, for the y-intercept, the point that crosses the y-axis, let me show you guys something real quick. Any point that I choose on the y-axis, I'm just going to choose random points. The coordinates of this one, the first one, is 0, 4. Coordinates of this other one is 0, 2. And the coordinates of this last one is 0, -1. Notice that any point on the y-axis, the x value is 0. So if I want to find out what the y-intercept is, so where do I cross the y-axis? I'm going to say the value of x is 0. So now that you have those, solve for it. Solve for the other variable here. So looking at the first question, y equals 0. So I'm going to do 2x plus 0 equals 4. Solve for x. Right? That 0 basically we can say it's gone, doesn't exist. So I have the 2x equals 4. Now divide both sides by 2, x equals 2. So my x-intercept, or where do I cross the x-axis, is the point 20. Now we want to know where do we cross the y-axis. I'm going to solve this where x equals 0. So I have 2 times 0 plus y equals 4. I know 2 times 0 is 0. So I have that 0 plus y equals 4. We can ignore that 0. So we get the y equals 4. So the y value is 4. Notice how I have my two coordinates. And the reason why we call this very, very important points, the intercepts, because those 2 points are enough for me to make my line. The point 20, it's this one. That's where I cross the x-axis. Now, the y-axis, I'm going to cross it at 0, 4. Remember, the y-axis is the one that goes up and down. 0, 4 is right here. Now that I have those 2 points, I'm just going to connect my points. Once again, sorry for my line right there, but it's supposed to be straight. You have the tools in My Math Lab, so it's about that. So once again, the intercepts are the points where we cross the axis. The first one is where do we cross the x-axis, where do we cross the y-axis. So that's what we call the intercepts. Another way how to graph, let's take a look. Something like this. I'm going to choose values of x, right? Random numbers. But notice how I have a fraction. I'm dividing by 2. So I'm going to values of x I'm going to choose. I'm going to make sure I can divide them by 2. So I'm going to choose 0 because I can easily divide that by 2. Let me choose 2, right, because I can easily divide that by 2. And I can also use negative numbers. Let me use -2. right? These values of x are just random numbers. You can choose any numbers you wish. So let's take a look. If x equals 0, let me work this out. I have y equals negative 3 over 2 times 0 plus 3. In my operation, a fraction times 0, we learned that anything times 0, fraction or whole number or anything times 0 is 0. So I have that y equals 0 plus 3. We can say that y equals 3. So boom, I found my first point. Let me erase this. For my second point, we said x equals 2. So I'm going to go y equals negative 3 over 2 times 2 plus 3. All right, so y equals, I know negative times positive. I know my multiplication there is negative. But remember I always said whenever we have a whole number, we multiply to the top and we divide to the bottom. It doesn't matter whether you multiply first and then divide, or you divide and then multiply. Whichever way you go, you're going to get 3. Right? Either you go 2 times 3 divided by 2, or you go 2 divided by 2 times 3. Once again, we start with the whole number, we multiply and we divide. We multiply to the top, we divide with the bottom. It doesn't matter which one goes first. So once again, I got a 3, and then plus 3, right? The plus 3 is right here. So negative 3 plus 3, that means that y equals 0. So that's good. Now for my last point, let's try y equals negative 3 over 2 times a negative 2 plus 3. So I see negative times negative, my fraction is going to be positive. Remember, multiply to the top, I divide with the bottom. So whichever method you go, 2 times 3 divided by 2, or 2 divided by 2 times 3, you get 3 plus another 3. Okay, so y equals 6. So those are the 3 points that we have. We can come up with more points. Now let me plug them in. And once again, if they don't look like a line, I made a mistake somewhere. My first point, my first coordinates are the point 0, 3. So that's right there. The second point are the points 2, 0. That's right there. The last one is negative 2, positive 6. So 2 to the left and 6 up. 1, 2, 3, 4, 5. So it looks like it's going to be somewhere right there. All right. Technically, for a line, I only need 2 points. I came out with 3 just to double check my work. It does look like a line. So when you guys do your line on my math lab, it's gonna look something like that. Gonna do the lines. It might not reach the point because the point is out of our graph, but that's what it looks like. So once again, get points, any points you want for x. I chose even numbers because we were gonna be dividing by 2. If I would have chosen an odd number, we would have dealt with decimals, and those are never fun to deal with. So make sure you can easily get rid of fractions. Let's take a look at this one. Graph the linear equation. You guys learned your intercepts. So I'm going to say x equals 0. That's going to give me my y-intercept, right? Where do I cross the y-axis? Then I'm going to say y equals 0. That's going to tell me where do I cross the x-axis. This method works great whenever these values are different. I'm going to mention that right now. I'm going to say what I mean in a minute. So let's take a look at this. X minus 3y, and I'm going to say, all right, let's choose the value. Let's let x equal 0. So we have to solve for y. So we have 0 minus 3y equals 0. So I have that negative 3y equals 0. Divide by negative 3. So y equals 0. Good. That gives me the y-intercept. I mean the x-intercept. Or the y-intercept, yeah. Now looking for the x-intercept when y equals 0, I'm going to do this again. But now y equals 0, so I have x minus 3 times 0 equals 0. I know this whole thing, this multiplication is 0. So I have x minus 0 equals 0. I get x equals 0. Good. So I did the work. But realize that both cases, I get the point 0, 0, which is this point. Once again, the graphing the intercepts, it works great when they are different points. But whenever it is the same point, like in this case, it's not going to work. It's not going to help us out. So we had to choose a different point. Right? Graphing the intercepts was not that nice because he gave us the same point. So find another value. So let me extend my table. I'm going to say, all right, so I'm not going to choose 0 for x because it's going to give me a point I already have. Let's say I let x equals 3, just to choose a number. Okay, so solve for y. So I have the 3 minus 3y equals 0. So I'm going to move this 3 over. So I have negative 3y equals negative 3 divided by the number in front of the y equals 1. Good. Now I have a different point. So I'm going to go 3 on the x, 1 on the y. If you guys wish, you guys can always look for a different point. Let x equals, let's say, negative 3. So do it over here. Negative 3 minus 3y equals 0. I'm going to move that 3 over. Negative 3y equals 3. Divide by negative 3. Y equals negative 1. So cool. So that gives us negative 3, negative 1. I'm like, all right, my 3 points do look like a line. So I'm just going to connect them. And let's call that a line, right? The best that I can do with what I have. So let's call that a line. Once again, on your MyMathLab, you have tools, so that should look like real lines. Whenever you guys do it on paper for quizzes or tests, you can always use the edge of an ID or something straight to help you. But it should look something like that. Once again, the intercepts are nice when they are different points. But when they're the same point, you have to find at least one more point. Now let's talk about special cases. There's going to be a couple special cases. The special cases are when there's only one letter. Like for example, x equals 4. Right? If you want, you can plug in 2 points. Remember the x value is 4, so you could do 4, 0, 4, 1, 4 anything. Like the y value doesn't matter. So if you see 1, 2, 3, 4, 4, 0, 4, 1. So this is the line x equals 4. I know the x-axis is this, but x equals 4 is the opposite way. The y-axis looks like x equals something. As a matter of fact, the y-axis has a different name. We call that x equals 0 or y-axis. Notice I changed the letter. So the y-axis is the same thing as x equals 0, so it makes sense that x equals 4 looks like the y-axis. So one case is when the x is by itself. The other case, let me change it to blue, is when the y is by itself. Let's say I have y equals, let's choose a value, negative 2. Right? You can plug in some points. The x value doesn't matter as long as the y equals negative 2. So you could choose any point. Like you can even choose a third point. Oh, it's just that the y is always negative 2. So we have 0, negative 2 gives us this point. 1, negative 2, 2, negative 2. Notice how it does look like a line. That one came out as a nice line. So this is the line y equals negative 2. Notice how this is the x-axis, Another name for the x-axis is y equals 0. So y equals -2 is down. So once again, the special cases is when we have one letter only, either the x equals 4 in this case, or we have the y by itself. Those are the special cases because they either give us a vertical line or a horizontal line. When we have two variables, x and y, they usually slanted. But these are the two special cases. So if you guys forget kind of how they look like, look for points in there. Remember, x equals 4. Give me values of points where the x value is 4, right? Plot in some points. For the other case, y equals something, in this case -2, give me values of some points, but the y value is -2. So that's basically what's going to help you.